In 2013, a team of paleontologists working in Niger's Sahara Desert made an announcement that stunned the scientific community. They reconstructed the skull of an ancient crocodilian, and it measured nearly 6 feet long. 6 feet, just the skull. The creature attached to it was something that should not have been possible. A crocodile so massive it made modern saltwater crocodiles look like pond dwellers. This was Sarcosuchus imperator, the flesh crocodile emperor, and everything about it defied what we thought we knew about crocodilian biology. But here is what makes this discovery so unsettling. This was not some distant dinosaur-era fantasy. Sarcosuchus lived just 112 million years ago, in a world that was already recognizable. Flowering plants were beginning to spread, early birds were taking to the skies, mammals were diversifying in the shadows. And in the rivers of what is now North Africa, there was a crocodile that weighed as much as an elephant. The first fragments of Sarcosuchus were discovered in the 1940s and the 1950s, scattered across the Sahara in what used to be a vast river system. But it was not until the 1990s and the early 2000s that paleontologist Paul Sereno and his team began piecing together a complete picture. What they found was staggering. A nearly complete skull, massive vertebrae, armor plating that looked more like a tank than a reptile, and teeth that told a story of an apex predator unlike anything alive today. When they measured the fossils and ran the numbers, the estimates were almost too extreme to believe. Sarcosuchus reached lengths of 39 to 40 feet, possibly longer. It weighed somewhere between 8 and 10 tons. To put that in perspective, the largest saltwater crocodile ever reliably measured was just over 20 feet and weighed maybe 2,000 pounds. Sarcosuchus was twice as long and 5 times heavier. This was not just a big crocodile. This was something operating on an entirely different scale. But size alone does not tell the full story. What makes Sarcosuchus truly bizarre is how it achieved that size, and what it did with it. Modern crocodiles follow a pretty predictable pattern. They grow throughout their lives, but their growth slows dramatically after reaching sexual maturity. A modern crocodile might live 70 years, but most of its growth happens in the first 10 to 15 years. Sarcosuchus did not follow that pattern. Studies of its bone structure show continuous rapid growth well into what we would consider old age. Some estimates suggest Sarcosuchus did not reach full size until it was 50 or 60 years old, and it may have lived well beyond that. Imagine a predator that just kept growing year after year for decades, getting bigger, stronger, more dangerous with every passing season. And then there is the skull. That 6-foot-long skull wasn't just oversized, it was weird. The snout was long and narrow, almost delicate-looking compared to the crushing jaws of modern crocodiles. But at the very tip, there was something no living crocodile has. A bulbous expansion, a rounded knob of bone that gave the snout an almost paddle-like appearance. Scientists call it a bulla, and to this day, no one is entirely sure what it was for. Some think it was used to create noise, a resonating chamber for bellowing during mating season. Others suggest it helped with the sense of smell, enhancing its ability to detect prey in murky water. Still others think it might have been used as a tool, a specialized structure for scooping or stunning fish. The truth is, we don't know, and that uncertainty makes Sarcosuchus even more alien. The teeth tell their own story. Unlike modern crocodiles, which have relatively uniform teeth designed for gripping and tearing, Sarcosuchus had differentiated dentition. The teeth at the front were long, sharp, and interlocking, perfect for grabbing and holding slippery prey. Further back, the teeth became shorter, more robust, built for crushing and processing. This wasn't a mindless biter. This was a precision predator with tools for different jobs. And the bite force? Estimates suggest it could exert well over 18,000 pounds of force, enough to crush bone, shell, and armor with ease. But to really understand what made Sarcosuchus so exceptional, we need to understand the physics of being this large. There is a concept in biology called the square cube law, and it puts brutal constraints on how big an animal can get. As an animal doubles in length, its volume and mass increase by a factor of 8. But its cross-sectional area, the strength of its bones and muscles, only increases by a factor of 4. This means that as animals get bigger, they become proportionally weaker relative to their own weight. It is why elephants have thick, columnar legs, while mice can scurry on delicate limbs. It is why blue whales need the buoyancy of water to survive. Sarcosuchus was pushing hard against these physical limits. On land, it would have been nearly immobile, its massive weight crushing down on its skeletal structure. Every movement would have been labored and exhausting. Its internal organs would have been compressed by its own bulk. Its heart would have struggled to pump blood through such an enormous body. But in water, everything changed. Buoyancy negated most of its weight. Its body became streamlined and hydrodynamic. Those powerful limbs, useless on land, became efficient paddles. The tail, thick and muscular, provided propulsion. In its aquatic environment, Sarcosuchus was not just viable, it was optimized. And this tells us something crucial about Cretaceous ecosystems. For Sarcosuchus to reach this size and maintain it for millions of years, the environment had to be extraordinarily productive. There had to be abundant prey, stable temperatures, and reliable water sources. The rivers of Cretaceous Africa were not just habitats, they were biological factories, churning out biomass at a rate that could support multiple giant predators. So where did Sarcosuchus live? And what kind of world could support a creature this enormous? The fossils come from the Elorhaz Formation in Niger, a region that 112 million years ago was nothing like the desert it is today. This was a lush, tropical river system, part of a massive inland waterway that stretched across what is now the Sahara. Rivers crisscrossed the landscape, fed by seasonal rains and monsoons. Swamps and floodplains teemed with life. Forests lined the riverbanks, and in those waters, Sarcosuchus was king. The climate was hot and humid, with average temperatures significantly higher than today. Year-round warmth meant that cold-blooded reptiles could maintain high metabolic rates constantly. There was no winter dormancy, no seasonal slowdown. Growth could continue uninterrupted. Hunting could happen anytime. And for a creature that lived as long as Sarcosuchus, this meant decades of continuous growth in optimal conditions. But it was not alone. The Elorhaz Formation was packed with other giants. There were massive sauropod dinosaurs, long-necked herbivores that would come to the water's edge to drink. There were large theropods, carnivorous dinosaurs that hunted along the riverbanks. There were giant fish, some measuring 10 feet or more, armored with thick scales. There were turtles, the size of small cars. And there were other crocodilians, smaller than Sarcosuchus, but still formidable. This was an ecosystem built for giants, a world where being big was not just an advantage. It was a requirement for survival. One of these dinosaurs deserves special mention because it likely had frequent, fatal encounters with Sarcosuchus. Ouranosaurus was a medium-sized herbivorous dinosaur, 24 feet long, with a distinctive sail on its back. Fossil evidence from the same formation shows these animals congregated near water sources, making them perfect targets. Imagine a young Ouranosaurus, perhaps separated from its herd, approaching the river to drink. It is cautious, nervous, aware that danger lurks in the water. But thirst drives it forward. It lowers its head to drink, and in that moment of vulnerability, the water explodes. Sarcosuchus erupts from the shallows, jaws agape, moving with shocking speed for something so massive. The teeth clamp down on the dinosaur's neck. The weight of the crocodile, 5 tons of muscle and bone, drags the Ouranosaurus into deeper water. The dinosaur struggles and thrashes, but it is already over. Sarcosuchus begins to spin, the death roll, and the violence is incomprehensible. Sarcosuchus was built for this environment. Its body was heavily armored with osteoderms, thick bony plates embedded in the skin that ran along its back and sides. These were not just for protection. They also acted as thermal regulators, absorbing heat from the sun and helping to maintain body temperature. In the tropical climate of Cretaceous Africa, this would have been crucial. A reptile this large needed to manage its internal temperature carefully. Too hot, and its metabolism would go into overdrive. Too cold, and it would become sluggish and vulnerable. Osteoderms played a key role in that balance. But here is where Sarcosuchus gets really interesting. Unlike modern crocodiles, which spend much of their time basking on riverbanks, Sarcosuchus was probably almost entirely aquatic. Its sheer size would have made movement on land slow and exhausting. Water provided buoyancy, support, and cover. In the murky, tannin-stained rivers of Cretaceous Africa, a 40-foot crocodile could disappear almost completely, submerged with only its eyes and nostrils breaking the surface. The positioning of those eyes and nostrils tells us a lot. They sat high on the skull, allowing Sarcosuchus to remain almost completely submerged, while still maintaining visual surveillance of the riverbanks. The eyes themselves were relatively large, suggesting good vision even in low light conditions. And the nostrils, positioned at the very tip of that strange bulbous snout, could break the surface without creating any disturbance, no ripples, no movement, nothing to alert prey that death was waiting just beneath the water. Nostrils and eyes together made it a perfect ambush predator. And it could wait. Modern crocodiles are ambush predators, capable of remaining motionless for hours, even days, until prey comes within striking distance. Sarcosuchus would have taken this to an extreme. Its size meant it had enormous energy reserves. It did not need to eat constantly. One massive meal, a dinosaur, a giant fish, a large turtle, could sustain it for weeks or even months. So it could afford to be patient, invisible, a living trap waiting for the perfect moment. Invisible was an advantage. Research into crocodilian metabolism gives us insight into how this worked. Crocodiles have one of the most efficient digestive systems in the animal kingdom. They can extract nutrients from prey that other predators would leave behind. Bones, hide, scales, everything gets broken down and utilized. And they can slow their metabolism to an almost hibernation-like state when food is scarce. Sarcosuchus, with its enormous gut capacity, could have swallowed prey whole or in massive chunks, then spent weeks slowly digesting, barely moving, conserving energy until the next opportunity arose. When it struck, the attack would have been catastrophic. Biomechanical models suggest that Sarcosuchus could generate enormous explosive power in its initial lunge. The narrow snout would have allowed it to move quickly through water, minimizing drag. The interlocking teeth would have clamped down with vice-like precision. And once it had a hold, there was no escape. Modern crocodiles use a technique called the death roll, spinning their entire body to tear chunks of flesh from their prey. Sarcosuchus, with its massive bulk and incredible bite force, could have done the same, but on a scale that is hard to imagine. A 10-ton crocodile spinning with a dinosaur in its jaws would have created a maelstrom of violence in the water. But the death roll served another purpose beyond dismemberment. It was a drowning technique. By spinning and dragging prey deeper, Sarcosuchus ensured that even if its bite was not immediately fatal, the victim would drown within minutes. For an animal this large, drowning was often the preferred kill method. A clean bite to the neck or head might work on smaller prey, but a full-grown dinosaur required sustained pressure, disorientation, and the relentless force of being held underwater by something you could not possibly overpower. What did Sarcosuchus actually eat? The evidence is frustratingly incomplete. Unlike some fossil sites where we find preserved stomach contents or bite marks on prey animals, the Ehlers Formation has not given us that smoking gun. But we can make educated guesses based on what lived alongside it and what its anatomy tells us. The long, narrow snout and sharp front teeth suggest it was specialized for catching fish. Large, fast-moving fish would have been abundant in the river systems. And Sarcosuchus' snout design is remarkably similar to modern fish-eating crocodiles like the gharial, just scaled up to monstrous proportions. But fish alone could not sustain an animal this large. Sarcosuchus almost certainly hunted larger prey as well. Young or medium-sized dinosaurs that came to the water to drink would have been perfect targets. A quick lunge from the shallows, a devastating bite, and a drag into deeper water. Once submerged, even a powerful dinosaur would have struggled against Sarcosuchus' weight and strength. Giant turtles, protected by thick shells, would have posed no problem for those crushing back teeth. And other crocodilians, competitors, and potential threats would have been eliminated without hesitation. There is also evidence that Sarcosuchus may have been more active than modern crocodiles. The structure of its tail suggests powerful swimming ability. The vertebrae in the tail were large and robust, with prominent processes for muscle attachment. This means the tail muscles were massive, capable of generating tremendous thrust. The arrangement of its limbs, while not built for running, shows adaptations for strong propulsion in water. This was not a passive, sit-and-wait predator like many modern crocs. This was an active hunter, capable of pursuing prey through the water, using its size and speed to overwhelm victims before they could reach the safety of the shore. Think about what that means. A 40-foot crocodile actively chasing down prey in open water. Modern saltwater crocodiles can swim at speeds of up to 18 miles per hour in short bursts. Sarcosuchus, with its larger tail and more powerful muscles, might have been even faster. Imagine being a large fish or a swimming dinosaur, glancing back to see a living torpedo of scales and teeth bearing down on you, jaws opening wide enough to swallow you whole. There would be no escape, no hope, just the awful realization that you were about to become food. And then there's the question of territoriality. Modern crocodiles are fiercely territorial, especially large males. They control stretches of river, driving out competitors and establishing dominance through displays of size and aggression. Sarcosuchus, being so much larger, would have operated on a completely different scale. A single adult might have controlled miles of river, an entire ecosystem unto itself. Smaller crocodilians would have been forced into marginal habitats, shallow streams, and backwaters, anywhere the giant could not follow. And encounters between two adult Sarcosuchus would have been rare, but absolutely brutal. We can infer this from modern crocodile behavior. When two large males meet, the battles are savage. They bite, they roll, they try to drown each other. Scars and missing limbs are common among dominant males. Now scale that up to Sarcosuchus. Imagine two 40-foot crocodiles battling for territory. Their massive jaws clamping down on each other, their bodies thrashing with enough force to uproot trees and reshape the riverbank. The sound alone would have been terrifying, bellows and hisses echoing across the water, audible for miles. And the victor would take everything: the best hunting grounds, the deepest pools, access to mates. Because reproduction would have been another challenge for an animal this size. Modern crocodiles build nests on riverbanks, mounds of vegetation, and mud where they lay their eggs. The female guards the nest for months, protecting it from predators. When the eggs hatch, she carefully carries the babies to the water in her jaws. Sarcosuchus would have followed a similar pattern, but everything would have been amplified. The nests would have been enormous, containing dozens of eggs, each one larger than a football. The female would have been ferociously protective, attacking anything that came near, and the babies, even as hatchlings, would have been formidable, probably 1 foot or more in length, already equipped with sharp teeth and predatory instincts. But survival rates would have been low. Even with a protective mother, young Sarcosuchus would have faced threats from every direction: large fish, other crocodilians, carnivorous dinosaurs. Even adult Sarcosuchus would have seen the hatchlings as easy meals. Only a tiny fraction would have survived to adulthood, but those that did would have had decades to grow, to learn, to dominate. And eventually, they would become the apex predators, the rulers of the rivers, just like their parents. There is something deeply fascinating about the growth trajectory of Sarcosuchus. Unlike mammals, which have determinate growth and stop growing after reaching adult size, crocodilians have indeterminate growth. They never truly stop growing. The rate slows down, but it never stops completely. For Sarcosuchus, this meant that the oldest individuals were also the largest, the most experienced, the most dangerous. A 60-year-old Sarcosuchus would not just be bigger than a 30-year-old. It would be smarter, more patient, more efficient. It would know every bend in the river, every sandbar, every hiding spot. It would have learned which prey was easiest to catch, which routes dinosaurs used to access water, when and where fish congregated. It would be the ultimate predator, honed by decades of survival. But despite all this power, all this size, all this evolutionary success, Sarcosuchus disappeared. By the end of the Cretaceous, it was gone, along with many of the other giants that defined its world. And the question is, why? What could possibly bring down an apex predator this dominant? The answer, as always, comes down to environmental change. The river systems of Cretaceous Africa were incredibly dynamic, shaped by seasonal monsoons and shifting tectonic activity. But around 100 million years ago, things began to change. The climate became more variable. Wet seasons became less predictable. Rivers that once flowed year-round began to dry up seasonally. And for a creature as large as Sarcosuchus, this was a death sentence. Here is the brutal math of being a giant. Larger animals need more food, more space, and more stable conditions. When resources become scarce, smaller animals can adapt more quickly. They can migrate, change their diets, or enter dormancy. But a 10-ton crocodile cannot just pick up and move to a new river system. It cannot survive on scraps. It needs abundant, reliable prey and deep, permanent water. As the rivers of North Africa became less stable, Sarcosuchus habitat fragmented. Populations became isolated, breeding became more difficult, and slowly, inexorably, the species declined. The geological record shows this transformation in detail. Sediment layers that once indicated year-round river flow begin to show signs of seasonal drying. Mud cracks appear, evidence that riverbeds were exposed to air. The diversity of aquatic life decreases. Fish fossils become rarer, and the giants, creatures like Sarcosuchus, that depended on abundant water, begin to disappear from the fossil record. But there was another factor, something more insidious: competition. During the Cretaceous, crocodilians were diversifying rapidly. New species were evolving, each adapted to different niches. Some were small and agile, specialized for hunting in shallow water. Others were heavily armored, designed to crush mollusks and crustaceans. And some were becoming more terrestrial, moving onto land to exploit resources that Sarcosuchus could not access. As the environment changed, these more adaptable species thrived. Sarcosuchus, locked into its role as a gigantic aquatic ambush predator, could not compete. It was too specialized, too dependent on conditions that no longer existed. One of these competitors was Sarcosuchus, a smaller, more agile crocodilian that lived in the same region. Where Sarcosuchus was massive and slow, Sarcosuchus was quick and versatile. It could hunt in shallow water, on land, even climb onto fallen logs to bask. When the rivers began to dry up, Sarcosuchus could move to smaller streams, temporary pools, anywhere there was water. Sarcosuchus could not. It needed deep, permanent rivers. And as those rivers disappeared, so did Sarcosuchus. And then, of course, there was the broader context. The Cretaceous was a time of tremendous change. New dinosaur species were evolving, flowering plants were spreading, insects were diversifying, the entire structure of ecosystems was shifting. And in this rapidly changing world, being a giant became a liability. The very traits that made Sarcosuchus successful, its size, its power, its dominance, became handicaps when the world it evolved for disappeared. There is a concept in evolutionary biology called evolutionary debt. It is the idea that adaptations that make a species successful in one environment can become fatal weaknesses when that environment changes. Sarcosuchus had accumulated enormous evolutionary debt. Its entire body plan, its metabolism, its reproductive strategy, everything was optimized for a world of abundant water, stable temperatures, and plentiful prey. When that world vanished, Sarcosuchus had nowhere to go. It could not evolve fast enough to keep up with the changes, and extinction was inevitable. By 95 million years ago, Sarcosuchus was gone. The rivers of Africa were ruled by smaller, more adaptable crocodilians. The age of the supersized river monsters was over, and in the fossil record, all that remained were scattered bones in the desert, silent witnesses to a time when crocodiles grew as large as buses and hunted dinosaurs in rivers that no longer exist. But here is what haunts me about Sarcosuchus. It is not just that it was big. Lots of prehistoric animals were big. It is that it was so perfectly adapted, so successful in its environment, and yet so fragile. A few degrees of climate change, a shift in rainfall patterns, and an apex predator that ruled its world for millions of years simply vanished. There is a lesson there, a reminder that no matter how dominant a species becomes, no matter how well adapted, the environment always has the final say. And when you look at modern ecosystems, you see echoes of Sarcosuchus everywhere. The largest crocodiles today, saltwater crocodiles and Nile crocodiles, are pushing against the same limits. They live in environments that are rapidly changing, fragmented by human activity, destabilized by climate shifts. They are the last remnants of a lineage that once produced true giants, and they are hanging on by a thread. Modern saltwater crocodiles can reach 20 feet and weigh over a ton. They are impressive, formidable predators. But they are shadows of what their lineage once produced. And they are facing the same threats that killed Sarcosuchus: habitat loss, climate change, reduced prey populations. The parallels are unsettling. We are watching in real time as environmental changes push these animals toward the same fate that claimed their giant ancestor. Sarcosuchus was not just a crocodile. It was a warning written in stone, a reminder that size and power mean nothing when the world itself shifts beneath you. For millions of years, it was the emperor of the rivers, unchallenged, unstoppable. And then the rivers changed, and the emperor died, leaving behind only bones and questions in the sand. Questions about what it means to be truly adapted, truly successful, and whether any creature, no matter how powerful, can survive when its world transforms beyond recognition.